So hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with our lead code question number 50, which says power of x of n. It is also a medium level question. So let's see what this question says. It says implement power of x comma n, which calculates x raised to the power n, that is x to the power n. So like this, here we have given, let's see example 1, x equals to 2.00 and n equals to 10, and we have given our output as 1024, means 2 to the power 10 equals to 1024. So that's the only thing we have to count. Okay, similarly in the second example also like this, and in third example also like this. So our power can also be negative. Okay, we have to keep this thing in mind so that our all test case will run smoothly. So let's take the example 1. So here's our example, it is 2 to the power 10. So we will approach this problem in binary, like with the help of binary exponentiation. Okay, so how we can perform this? We can distribute it like this: 2 into 2 whole to the power 5. Okay, cool. Let's write totally. We can write it like this, and then it can be break down into 4 to the power 5 like this. Okay, no problem. Then again, it can be break down into 2. No, no, no. Now we can see our power is odd. So basically here we will follow two methods. Okay, if and else kind of. If this, then that. We will always check our power. If it is even, then what we will do, we will double our this, the value like this, and make it half like this. Okay, but if it is odd, we will simply add our original value to answer, means our final result, and then again write that value with one less power like this. Okay, so this is totally correct, we can write this. So now we will move further with this. Okay, so now 4 to the, we can write it like this: 4 into 4 whole to the power 2. Okay, that's totally right. It becomes 4 into 16 like this. Okay, cool. Now again we will break it like this. Okay, that's also fine, and then it becomes like 256 to the power 1. Now what we will do, we will, now its power is odd, so we will store this answer at result, means this is our result now, and then reduce power by 1 like this: 256 to the power 0. So it becomes like this: 2 into 56, which will be 1024. So this is how we are gonna get our answer. Okay, so that's the only approach we are gonna follow here. This is how we can perform this question solution. But here's also the case when our power is negative. So how we can perform these type of question when the power is negative? In that question, first of all, we will check this thing, that if our power is negative, means our we here it represents m, na, means sorry, n. So if our n is smaller than 0, it means that means our power is negative. So we will convert, we will basically reciprocal our number, means x become 1 by x, and then we will make our power positive like this. Sorry, here it was n like this. Okay, like this. Let's take the example. Here's our example. Example number third. Here x equals to 2 and n equals to minus 2. So to make this positive, we will, what we will do, we will reciprocal it, means now x becomes 1 by 2, and now the power can be 2, because this both means same. 2 to the power minus 2 means 1 upon 2 to the power 2, and this also means 1 upon 2 to the power 2. That's it, that's simple. So now let's jump down the pseudo code and see how this all is happening in the code. So let's write down the pseudo code. First of all, we'll create a new variable which will be m, where we will store the value of n, so that we don't modify our original value, and we will modify a new value which we are storing here, and also create an answer equals to a double value, because we want our answer in the float. That's why we are creating this value. Now we will check for the negative value. If our m is smaller than 0, then we will modify our x as 1 by x and our m as minus m. Now we are converting our m to positive. Okay. Then after this, we will jump to our main function, that is our while loop, which will run till our m is greater than 0. Okay. Here m is our power. It represents power. So if our power is even, then what we have discussed earlier, if our power is even like this here, so we will multiply our value with itself only and reduce its power by half. So we will do the same. We will multiply its value by itself only and reduce its power by half. Okay, it's fine. But if our power is odd, then what we will do? We have discussed, if my power is half, then what we will do like this. Here it is half. We will simply send the value to the add to our multiply to our result, and then again write the value and reduce the power by 1. We can see the power is reduced from 5 to 4. So that's the only thing we are gonna do here. We will multiply that value, first of all our value of x, to the answer, and then we will reduce our power by 1 like this. That's it. After this while loop, we will simply return our answer, which will be storing our final value. Cool. That's it. This is how we are gonna approach our problem. Let's take another example like this. That third example, that is where x equals to 2 and n equals to minus 2. First of all, what we will do, we will store our value. Means now our m equals to minus 2 and our answer equals to 1.0. Now we can see that our m is smaller than 0. So what we will do, we will reciprocal our x. So now our x becomes 1 by 2 and our m becomes 2 and our answer is 1. So these are our final values in which we have to form our further calculations. Now we will check our m is greater than 0. So what we will do, because we can check that m is greater than 0, then we will check the first condition, that the m is even or not, and we can see that our m is even. So we simply multiply our value of x like this. X becomes our 1 by 2 into 1 by 2, which means 1 by 4. Great. And our m becomes half, means 2 by 2 equals to 1. Okay, so now our x is this, m is this, and our answer is 1.0, like this only. Now we'll again iterate toward this condition. Now we can again see that m is still greater than 0. So what we will do now, our m is odd, so we will jump to the next condition, that is else statement. So it says that answer becomes answer into value of x. So now our answer becomes, this is on first iteration, this is on second iteration, our answer becomes 1.0 into 1 upon 4. Okay, that's same, 1.0 upon 4. Great. Now again we can see our m reduces by 1. So now our m becomes 0 because our m is reduced by 1. Now we will again iterate to our loop. We can see that m is now not greater than 0. So we will simply return our answer, that is this. So I guess now we have to convert it. Yeah. See. So now we can write this as 0.25. This will be our final output, like here above. So that's it. This is how we're gonna approach this problem using binary exponentiation. So below I will provide you the code. Let's discuss the code. So here is your code for the following problem. It's same. First we have created a variable m where we store the value of n. Then we create an answered one. Then the same conditions, check if our m is even, means our m is negative or positive. Then we have all the conditions that we have done for the even case and for the odd case, and at last we have returned the answer. Great. So now let's discuss the time complexity. So the time complexity is big of log n. And why so? Because we have done binary exponentiation here. Okay, what is binary exponentiation means? Our value is decreasing something like this: 10, then 5, then it reduced to 4, then it reduced to 2, then 1, then 0. This is what that is why our value is big of log n. And the space complexity big of n, because we are not using any external space. So that's it. Thanks for watching. Bye bye.